What if your server could just talk directly to a user's browser? Send it JavaScript commands whenever it wanted. Today, we're diving into a really powerful technique that lets a Java server do exactly that, getting around the normal way of doing things to handle some pretty tricky situations. Let's break down how it all works.
So, before we get into the really cool stuff, let's just do a quick recap of how things usually work. When you're on a website, how does the server get your browser to execute a piece of JavaScript? The answer is probably exactly what you're thinking.
Yep, that's it. The server just tucks the JavaScript inside a simple little script tag in the page's HTML. Your browser loads the page, sees that tag, and boom, it runs the code. That's how the web's been built, right? Simple, effective, and super reliable. But what happens when that simple, reliable method just isn't an option? And this is where we get to the real problem. Imagine something critical happens, like the server has to restart. Now, the connection to your browser might still be open, but the server has basically lost its memory of the web page. It has no clear way to send new instructions. It's kind of like the phone line is still connected, but the person on the other end has totally forgotten who they were talking to. And this slide, man, it lays out the problem perfectly. On the left, you've got business as usual. The server has this thing called a browser page object. You can think of it as its control panel for your user interface. But look on the right, after our server restart, that control panel is just gone. The server is flying blind. It can't inject a new script tag because it literally doesn't know how to talk to the page anymore. So how do we fix this? Okay, so this is where a framework like wffweb comes in with a really clever workaround. Instead of trying to rebuild that lost control panel, it just opens up a new direct channel. It's like sending a sealed package directly to the browser. The server wraps up a command and just pushes it through the existing connection, completely bypassing the need for that missing browser page object. And the secret sauce in this sealed package is something called a byte buffer. You can literally think of it as a digital envelope. The server writes out the raw JavaScript command, seals it up inside this byte buffer, and just ships it off. The browser, on its end, is set up to receive this specific package, open it, and run the command inside. No questions asked. It's a direct, unambiguous instruction. All right, so what does this actually look like in the code? Let's walk through the Java for this. It's actually a super clean, two-step process that's way more straightforward than you might think. It really just boils down to this. First, we get our package ready. That means encoding our JavaScript command into the byte buffer. Then, once it's all set, we just send it straight to the browser. Prepare, then send. That's it. Now let's see the code for each of those steps. Okay, check it out. Here's the code for step 1. We're calling a static method here, getActionByteBuffer for execute.js. The fact that it's static is the whole key, right? It means we don't need an instance of that browser page object we lost earlier. This is exactly what we need for our disaster recovery scenario. We just pass in our JavaScript string, in this case, a simple alert, and this method does all the heavy lifting, encoding it into the exact binary format the browser is expecting. Our envelope is now sealed and ready to go. And now for step 2, we send it. We grab the client's existing WebSocket session, that's the persistent two-way communication channel that's still open between the server and the browser. Then we just call the sendBinary method and pass in our action byte buffer. This is that direct push we've been talking about. We're not sending HTML or text, we're sending a raw binary packet right down the pipe, which the client-side code is just waiting to receive and execute instantly. Now, it's worth pointing out that if you are in a normal situation and you do have that browser page object, the framework gives you a more conventional way to do this: perform browser page action. It gets the same job done through the standard object model. But it's that direct WebSocket push we just saw that's our real lifeline in those special failure scenarios. So you might be thinking, this is a cool technical trick, but why does it matter? Well, it's not just a trick. It fundamentally changes how we can build really robust applications. Having this kind of direct, low-level control from the server is an absolute game changer, especially in apps where reliability and security are completely non-negotiable. And this is where the power of this method really shines. I mean, think about a secure banking portal. The server can force a logout or pop up a critical security alert, even if the page's state is messed up. Or imagine a real-time trading dashboard. This direct push lets the server send updates with the lowest possible latency, making sure the data on your screen is instantaneous. It's all about giving the server ultimate control and rock-solid reliability. At the end of the day, this whole technique really redraws the lines of communication between the server and the browser, and it gives the server a much, much stronger hand. So it leaves us with a pretty compelling question. Once the server can directly and reliably command the client, what new kinds of truly resilient and secure applications can we even start to imagine building? Thanks for digging into this with me.